In COMSOL Multiphysics, you can separate any part of your model geometry by using partition operations. This can be useful in many instances. For example, if you want to split a geometric entity, such as an object, domain, boundary, or edge, if you want to remove parts of the geometry in your model, either to simplify your simulation or clean up the geometry, and also if you want to improve the mesh in your model. This functionality is especially advantageous for geometries that are complex or exhibit high aspect ratios. In this video, we will show you step by step how to partition your model geometry, using a few examples. In addition, we will show you how this feature can improve the meshing on more complex geometry and be utilized to simplify your model. To start, we are going to show you how to improve the mesh for a geometry by using partition operations. Here you can see we have a helix using the respective built-in primitive geometry operation. Let's now build the mesh for this object. We can do that by going to the Mesh tab and clicking the Build Mesh button. You'll notice that it takes quite a bit of time for the mesh for this object to be generated. We could improve the meshing of our object by simplifying the geometry using a partition operation to split it right down the middle. Right now we have a single, relatively complex domain that we are meshing, and splitting it in half would create several smaller, simple domains which are easier for the mesher to resolve. So now that we've identified the geometry we want to partition, we need to generate the tools by which our geometry will be split. So let's create a work plane to split our helix right down the middle. We can do that by returning to the Geometry tab and clicking the Work Plane button. In the Settings window, we'll want to go with most of the default settings. We will use the Quick Plane type here, but there are also various other options available, which you can learn more about by going through the chapter on work planes in your COMSOL reference manual. All we are going to change here is the plane to the YZ plane and click Build Selected. So now you can see that we have the work plane going right through the middle of our helix. Now we can add a partition operation to split the object. We can do that by going to the Booleans and Partitions button and selecting Partition Objects. Notice that the active switch under Objects to Partition is toggled on. This means that whatever objects we select in the graphics window right now will be added to our list of objects to be partitioned. So we can go ahead and select the helix. And now under Partition With, this is where we will choose the means by which our geometry is split. We have two options. We can partition our geometry using objects or a work plane. So since we defined a work plane to separate our geometry, let's select work plane. Notice that work plane 1, which we just created, was already selected by default. However, if there were other work planes in our geometry sequence, they would also show up here as options. Now we can go ahead and click Build Selected. And you can see our geometry has been split in half right down the middle. Let's now rebuild the mesh. So we can return to the Mesh tab and again click Build Mesh. You'll notice that rebuilding the mesh with our partitioned geometry went significantly quicker than previously, since instead of a single complex domain, we have several smaller, simple domains. This is great for our mesh, however, this does make things more complicated in terms of adding materials or defining physics boundary conditions. This is since we have now significantly increased the number of geometric entities in our model. To utilize the partitioned geometry for the mesh, but ignore it as we apply settings to our model, we can use the Mesh Control Domains virtual operation, which can be found under the Geometry tab under the Virtual Operations button, and then under the Mesh Control section. If you'd like to know more about how using partition operations can improve the meshing for a geometry, please see our blog post covering these such topics. Let's now move on and show how to simplify a geometry using partition operations. You'll see here our geometry consists of a heat exchanger, and I'll just turn on the transparency so it's a little easier to see internally. If we take a moment to observe the geometry, we can see it's symmetric along the XZ plane, with one side being a mirror image of the other. As such, we can split our heat exchanger geometry in half, remove one side, and use the remaining half to create our model. By taking advantage of the symmetry of the heat exchanger and only modeling one half, we are reducing the model size and computational costs of the simulation. To partition this geometry, once again, we can create a work plane that cuts straight through the middle. Besides adding our work plane and partition operation through the ribbon, we can also add it through the model tree. So first, since we need to create our work plane, we can right-click the geometry node and select work plane. Once again, we'll want to go with most of the default settings here, except we will want to change the plane to the XZ plane. So you can see once again we have a plane lying right down the middle of our imported geometry. Now that we have our geometry as well as the tool that we want to partition it with, we can add a partition objects operation. Once again, we can add it by right-clicking the geometry node, going under Booleans and partitions, and selecting partition objects. So just as previously, we can go ahead and select the objects we want to partition, which would be both the tube and the shell portion of our heat exchanger. And under partition with, right now it is set to objects, but we want to change that to work plane. And our work plane we defined is selected by default. So we can go ahead and click Build Selected, and our geometry has been split right down the middle. We can now delete the portion that we want to remove using the Delete Entities operation. So first, we'll want to change the geometric entity level to domain, and now we can select the domains on one side of our heat exchanger. Let's do the right half. And now you should be able to recognize this geometry as what's used in the shell and tube heat exchanger tutorial model. If we switch over to the complete solved model from the application library, you can see that the symmetry boundary condition in both the turbulent flow and heat transfer physics interface is applied to these new boundaries formed from the partition operation. These are the boundaries lying on the plane of symmetry, the XZ plane. With that, we have showed you how partitioning operations can come in really handy when you are dealing with complex geometries or geometries that exhibit a high aspect ratio. They can be used to simplify your model as well as improve and expedite the meshing of your geometry. When choosing to partition the geometry in a model, the procedure is as follows. You first identify the geometry you want to partition. Then, you create the geometry or the work plane, which will serve as the means by which your geometry is split. After that, you add your partition operation for the respective geometric entity level. Then, you select the geometry or work plane created as the tool to divide the geometry and build the operation.